that's cool. It would work that way. Okay. So which one? That would be on the second? No, the trig one. So that's the one you're looking for? Actually, no, it's not. You're probably looking for the one that's on just solving limits analytically with the delta x's, right? I think I know one. Yeah. Yeah, like something like that. Okay. Okay, let's try this one. Different one? Say it again. Oh, one question. Okay, I can do that. So, okay, like that one? Okay, let's look at that one. Okay. Yeah, the concepts can be the same, so this will work great. Okay, so it's telling us the answer, but we'll show that that's the answer. Okay, so this is the same kind of thing that we've been doing, only difference being that delta x is the variable of the limit. Okay, let's talk about that for a second. There are x's up here. X is obviously a variable of the function, right? But the limit is sensitive to changes in delta x. Okay, so as far as the limit is concerned, x acts like a constant. Okay? You get that? Because we're taking the limit as delta x approaches something, not as x does, right? And so if we try to evaluate this directly, we're going to get the delta x's go away, and I get 5x squared minus 5x squared, which is 0 on the top and then 0 on the bottom, right? So this is actually a really easy problem. It's just that it looks a little weird. You haven't seen anything like that before. So what would I do then to resolve this indeterminacy? What do you think? I could factor out the 5s. Yeah, okay, let's... I could... That's not a bad suggestion. I could factor... I've got two terms on the top, and I could factor out a 5, right? That would be fine. I'm not going to do it right now, though, just because I think it's going to interfere with the part I want you to see in the problem. It's actually a pretty good step. Okay? But I don't really need to do that. Obviously, I can't... Think about our strategies. Can I factor the top? Not really. I can't factor it directly, can I? Okay. Can I multiply by no, it's not going to work. Okay, I don't have any square roots here. Can I add up the fractions? Not really. This is something, it's kind of a hybrid. It's not really, it doesn't fit any one of those strategies really well. But bottom line, I just want to be able to simplify this, right, and get some cancellation. So why don't I just expand the top out and see what happens, right? By expand, you understand what I mean? I'm just going to multiply out x plus delta x quantity squared, right? Distribute to 5, and we'll see what happens. So this will look like then the limit of what happens. What is x plus delta x squared? X squared plus 2x delta x, or delta, right? X delta x plus delta x squared, right? Everybody agree? We're just using the pattern a plus b quantity squared is a squared plus 2ab plus b squared, right? Okay. So we get limit of 5 times the quantity x squared plus 2x delta x plus delta x squared minus 5x squared over delta x as delta x goes to 0 if I distribute the 5x squared plus what? Okay? On the top. Okay, good. I do some horizontal cancellation, which means canceling to 0, right? They add to 0, so they literally go away from the problem. Okay, now look at what's left. Now we can do some factoring, can't we? Right? Notice that the only term up here that didn't have a delta x in it was this first one, right? I call that the naked term. That's the one that didn't have a delta x, and so that's, actually there were two of them. Those are the ones that cancel. And they'll always cancel in situations like this. Okay? We'll see a lot more of this in the near future because as it turns out, this is the limit that evolves from our definition, soon-to-be definition of a derivative, which we'll get to. That doesn't mean anything to you now, but it will very shortly. So we're going to see a lot of limits that have this form in the near future. Okay? They're all going to work the same way. So the non-delta x, or the naked terms, cancel, and look what we have left. Each of the two terms has a delta x, so I could factor a delta x out of each term, couldn't I? Everybody see that? So then we end up with the limit of delta x times the leftover. What's left over if I factor a delta x out of those two? Good. All over delta x as delta x goes to 0. And now I can do some vertical cancellation. Cancel the 1, right? Cancel the factors like we've done in the past. Okay. Now the indeterminacy is gone. The 0 over 0 nature is gone. I can take the limit, right? So I wouldn't normally write out this extra step, but I'm going to this time just so you can see it clearly. And so what's going to happen? Well, what's going to happen to that term? It shrinks to 0, and I'm left with 10x.
Why is it 0?
Because delta x is going to 0, so 5 times 0. Okay. Okay, make sense? So they're no big deal. It's just it. But what's different about this is all the limits you've done in the past have been limits of functions of x as x approaches something, right? And so we end up with a y value that's a number. Didn't happen this time, though, because this time the variable of the limit was a delta x, and so the x's don't go away. Okay? Get it? Okay? All right, I'll let you work. Let me see.